Hey guys, in this video we're going to talk about section 1.1 and section 1.2 in the textbooks. In particular, we're going to talk about functions in terms of inputs and outputs, and we're going to look at a couple of different ways that we can view functions, as equations, as graphs, and as tables. So without further ado, let's go ahead and get started. So what is a function? So the easiest way to describe a function is with three different components. Okay, so a function takes something called an input, it applies a rule to it, and it turns it into an output. Okay, so one example that I have from real life is this 3D printer right here. So this is a 3D printer, and these things can print houses now. It's super cool. I believe that the fastest house that was printed was like it printed in under 24 hours. It was crazy. But yeah, anyway, so there's an input, a rule, and an output when you're 3D printing a house. And so the input is, whatever this material is that you feed into the 3D printer. Okay, so that's the input. And at first, it just starts out as raw material. It doesn't have any kind of shape. It's just, I believe that it's made with concrete and some other sort of material, but anyway, that's the input into our function. So the input, we can say, is the concrete mixture. Okay, so what is the rule? Well, the rule is the blueprint that the machine follows to make the house. Okay, so the rule is the blueprint that the machine, that the printer follows to make the house. And finally, we have an output. The final product is going to be the 3D printed house. So there's all kinds of different examples you can think of with functions, but I like this example because it's super relevant in our lives today. These 3D printers are popping up everywhere. But yeah, that is what a function is, simply put. Okay, so let's try to make the definition a little bit more abstract. Okay, so we're going to talk about functions in terms of equations, tables, and graphs. And the first thing I want to do is I want to kind of make this a little bit more abstract by putting numbers and operations into our function definition. Okay, so let's say that we have a rule to add 3 to the input. Okay, and let's say we feed into this function an input of 4. Well, what is the output going to be? Well, the rule tells me I need to add 3 to the input. So we take the input, which is 4, and we just add 3. So that's what the rule tells us to do, and we get an output of 7. Okay. If I wanted to talk about adding 3 to any input in general, not just 4, but any input, what would I do? Well, one way you can do it is you can say my function can be represented in the following way that's a little bit more abstract. We can say x plus 3 is my function. And that way, my input is x. And x is a variable, which means that we can replace any number we want into this function, okay, for our input. So that's one way that we can sort of make this definition a little bit more abstract. So in a function, we typically represent the input with x, not always, but usually, and the output with y, and we're about to learn f of x, which is function notation. Okay. So let's talk about function notation. Okay, so we have a function right here. Okay. And we don't have any inputs yet because we didn't make them up yet, but we know a few things, okay? we know on the left side of this equation that the function's name is f. Okay, so the function is named, I'll put that in quotes, f. Okay, that's what this f tells us. This guy in parentheses is our input. Okay, so that tells me that wherever I see an x is where my input values go. Okay, so this is my input right here. Okay, so let's go ahead and make up some input values and see what our output values are going to be. So this is what you do. You just choose randomly whatever x values you want. And so I usually just do like -2, -1 to get some negative numbers. Then I do 0, 1, 2. Very simple, but you could pick any input you want to. Okay? Now what we're going to do is we want to evaluate this function. And we're going to evaluate first at -2. Okay, so -2 is our input first. And all we're going to do is plug in -2 into my function where I see an x. And that's only one place on the right side. Okay, so now I can multiply these guys. 3 times -2 gives me -6. And there it is. That's my output. So when x is -2, f of x is -6. And I can do the same thing for these other numbers. Let's do f of -1. So we get 3 times -1 is -3. So my input is -1, my output is -3. Okay, how about 0? So if I plug in 0 into my rule, 3 times 0, I get 0. Okay. And when I plug in 1 into my rule, 3 times 1 is 3. And finally, when I plug 2 into my rule, 3 times 2 is 6. Okay, so there you have it. You have input and output values, and we found those by using this rule 3 times the input. Now, another thing that we can do, since we have a table that we just created, is we can graph some points. We can graph these points that we just found on a coordinate plane. So remember, with your coordinate plane, your x-axis is the horizontal. That's our input axis. And our y-axis, or our f of x axis, is going to be the vertical one. So the first point we have is -2, -6. So that's our first ordered pair, -2, -6. So I go to the left -2, and then I go down 6. So that is my first point. Next one, I have -1, -3. So I go to the left 1 from the origin, and then I go down 1, 2, 3 to land me right here. That's -1, -3. 0, 0 just goes through the middle like that. 1, 3. I go to the right 1, and from there I go up 1, 2, 3 to land me right there. And 2, 6 is going to be somewhere right here, okay? And notice that this kind of looks like a straight line, which it is, and we're going to talk more about this later, but that's another way that you can see functions. You can see them in a table like this. We just made up some inputs, got some outputs, and then what we did is we put the inputs and outputs on a graph like that to see that it makes a line, okay? Okay, so let's talk about independent and dependent variables. So an independent variable is basically just the input. A dependent variable is the output. And we call it dependent because it depends on the independent variable. So let's look at a real life function. So whenever you go to the restaurant, typically, if you're a nice person and if your waiter or waitress has done a good job, you usually leave them 20% for a tip. And the way that you do it is you just multiply 20% by the cost of your meal. And so we can actually make a function from that rule. The tip function, t, okay, instead of f, it's t, is a function that takes the cost of your meal, c, and then it produces the tip. Okay, and you do this naturally in your calculator. You always use a tip function, okay? And so this is how you do it. Okay, so the question is, what is the independent variable and what is the dependent variable? Well, ask yourself, does the cost of the meal depend on the tip, or does the tip depend on the cost of the meal? Well, of course the tip depends on the cost of the meal, right? The cost of the meal is independent of the tip. And so in this case, the tip is the dependent variable because it depends on the cost of the meal. And the cost of the meal is our independent variable. So let's talk about evaluating functions as equations. So in a couple of slides ago, we looked at the function f of x equals 3x, and we evaluated it at some inputs. So we're going to do the same thing for these guys. All right. So the first example says evaluate f of 3 if f of x is 2x plus 5. So this is my rule, 2 times the input plus 5. And so all I have to do is plug in 3 anywhere I see an x into my rule. And then on the right side, 6 plus 1 is just 7. So that's my answer. F of 3 is equal to 7. Okay, let's look at the next one. G of 2, if g of t equals t minus 8. Well, this time our input variable is t, which is totally fine. We can have whatever variable we want. It doesn't have to be x. And now, wherever we see a t, we're going to replace that with a 2. Okay, so g of 2 is equal to 2 minus 8 over 3. And that is going to equal, let's see, negative 6 divided by 3 is going to give us negative 2. So g of 2 is negative 2. All right, let's look at this one. H of 9 if h of x is equal to x squared minus x plus 4. So again, I'm just plugging in 9 anywhere I see my input variable of x. So this is going to be 9 squared minus 9 plus 4. 9 squared, 9 times 9 is 81, minus 9 plus 4. So 81 minus 10 is 71, so that's 72 plus 4 is 76. So h of 9 is 76. Let's do some more examples. So this says evaluate f of a if f of x is equal to x to the third plus 3x minus 6. Well, what does this mean, evaluate f of a? Well, we're just doing the same thing as if a were a number. We're literally putting in a anywhere we see our input variable in our rule. So we're plugging in a for all of these x's. Okay, we just act like it's a number, okay? So f of a is going to equal a to the third plus 3 times a minus 6. And of course, we don't have any like terms here, so that is our answer. That's f of a. Okay, now try to do this one. This one's kind of crazy, but it's okay. So this time we have this thing that we're inputting into our variable x. So wherever we see an x, we're inputting 2 plus s. Okay, so g of 2 plus s. I'm going to put a 2 plus s anywhere I see an x. Squared minus 2 plus s. Be sure to put those parentheses there. And now what I'm going to do, since I have 2 plus s squared, I'm going to do some scratch work over here. Because since this is a binomial, 2 terms, I need to FOIL this guy. Okay, so if you need a refresher on FOIL, I encourage you to rewatch the review video that comes before this. okay? So let's do FOIL. So I have 4 first, and then outer is plus 2s, inner plus 2s, and last is s squared, okay? So this becomes 4 plus 4s plus s squared. So I can just replace that right here. All right. And then this guy, this -1 in the front, can distribute, right? This is a 1. This is understood to be a -1. And so this becomes -2 minus s plus 1. That plus 1 is just at the end. Now I can combine like terms, and I'll write my highest power in the front. So I have s squared. Let's see. 4s minus s is a positive 3s. And then 4 minus 2, so that's going to be a positive 3. So that is my fully simplified answer. Okay. If h of x equals -3 minus x squared minus x minus 4 to the third, evaluate h of -1 and h of 1. Okay, so let's do h of -1 first. So anywhere we see an x, we're plugging in -1 into our function. We're going to be super careful to make sure that negative is in parentheses. That -1 is in parentheses. And the reason I'm doing that is because sometimes the signs get hairy and you make a mistake if you don't put it in parentheses. Okay. Alright, so let's do order of operations. We're doing inside the parenthesis first. Okay, these double negatives next to each other make a positive. So this becomes -3 plus 1 squared. Minus, okay, let's do in the parentheses right here. -1 minus 4 is -5 to the third. Okay, now PEMDAS says do parentheses first. So I'll simplify this guy. This is -2 squared minus -5 to the third. Okay, so -2 squared is just positive 4, -2 times -2, -5 to the third power. Okay, so that's going to be a negative number. If you put it in parentheses in your calculator, parentheses -5 to the third power is going to give us -125. Okay, so this right here is -125, and I still have that minus in front. So these double negatives, again, make a positive. So this just becomes 4 plus 125, which is 129. So that's h of -1 is 129. Let's do h of +1. This will be a little easier because I don't have to worry about the parentheses since we are not worrying about signs. So I have -3 minus 1 squared minus 1 minus 4 to the third. -4 squared is 16. -3 to the third is -27. So I have those double negatives, which makes a positive. And I'm super lazy, so I'm just putting that in my calculator. So we get 43. That's h of 1. Okay, the next thing we're going to talk about are functions as graphs, okay? So let's say that we're given this graph and we're told that it's f of x. Okay, so this curve is represented as f of x. Now, of course, the horizontal is always going to be x, and our vertical is f of x instead of y, like you're probably used to seeing. And so let's just jump right into it. We're going to do a bunch of these just to practice. F of 0, this means what is the output when the input is 0? Okay? What is the vertical value when the input is 0 in this graph? Well, when the input's 0, our output is going to intersect the graph right here okay, that is f of 0. When the input's 0, the output looks to be negative 12. Okay. Now let's look at the next one. The next one says, what input is going to give me an output of 0? In other words, what is the horizontal value that corresponds to a vertical value of 0? Well, we have 3 places where we don't have any movement in the up or down direction. Those places are right here, and right here. Let's see, 1, 2, 3 is going to be the positive one, so we have f of 3 equals 0. The negative ones, we have negative 1 and negative 4. So this is negative 1, and this is negative 4, and this is 3. So all 3 of those have an output of 0. Okay, let's do some more practice with this, because I know it kind of takes a second to get the hang of. Alright, so this is g of x. So again, our x-axis is horizontal, and our function, g of x, is going to be our vertical axis. So the first one says, when we have an x value of 0, what is the y value? That's what it's saying. When I have an x value of 0, what is the y value? Well, x value of 0 is right here. I'm not moving in the left or right direction, but I can move up, and that's going to be right here. Okay, and what y value is that? 1, 2, 3 is going to be that y value. So g of 0 is equal to 3. Okay, part B says g of what equals 0. So what input doesn't have any vertical movement, basically? What input doesn't have any vertical movement? That's going to have to be this guy right here. That's on the right horizontal axis, and that's at 1, 2, 3. So that's going to be 3 right there. Okay. Next one says, when my input is 10, what is my output? When my input is 10, what is my output? Well, let's look at the graph. So here's my input of 10, and now I want to just look to see where it hits vertically, and that's right here. Looks like 6, 7, at 7. So this is going to be 7. Okay, part D, g of what equals 10? There's 2 of them. So which input values have an output value of 10? So we want to look at the output axis, which is vertical, and then see where it hits the thing horizontally. And it hits it right here horizontally, and it hits it right here. So this first one is -6, -7. So we have g of -7 equals 10. And we also have, let's see, that looks like, let me see, g of 13. G of 13 also equals 10. Alright, the next one, what is g of 1 plus g of 2? Well, we need to figure out what the numbers are for g of 1 first, and g of 2. So g of 1, if we look at our graph, what is the output when the horizontal is equal to 2? Well, that's going to be right here. Okay, that's going to be at 1. Or, yeah, so g of 2 is equal to 1. And g of 1 is equal to 2, right here. So g of 1 equals 2. Therefore, g of 1 plus g of 2 we just replace. G of 1 is the same thing as 2, and g of 2 is the same thing as 1. So 2 plus 1 is 3, and that's my answer. Okay, the next one says, what is 3 times g of -7? Well, we know g of -7 is 10 from part D. So this is going to be 10. So therefore, 3 times 10 is equal to 30. Okay, so that's my answer here. All right, let's do another one like this. I told you I was going to do a bunch of examples with this. So let's look at this. This one, it looks kind of hard to see, but the x-axis is going to be right through here, and our y-axis is going like this. Okay, so our f of x axis. And so it says, what is the output when the input's 0? So what vertical value corresponds to an input of 0? That's going to be this guy right here. That's about 24. A height of 24. Now f of 1 is going to be right here, and that's at 10. F of b is going to be right here. And that looks like it's negative. I'd say negative 8-ish. F of c, that's just going to be 0 because it's not moving vertically. It's just on the x-axis. So f of c is 0. Now f of 0 from part A is 24. F of 1 from part B is 10. 24 minus 10 is 14. So that's my answer for part F. Okay. I think that was the last one. Okay, so the next thing we're going to talk about, we're going to talk about functions as tables, okay? So let's just go ahead and do this example quickly. So it says evaluate t of 50 and interpret its meaning from this table right here. So it tells us what this is. This is cellular charges for 1 month. And we have minutes on the left and our total charge on the right. Now, since I'm putting this inside of t, this is my input, so I know that this is going to be minutes. So t of 50 means, what is my output when my input is 50 minutes? Well, that's going to be $25. And so what does this say? That says when I use 50 minutes of data, my cell phone bill is $25. Okay. Alright, so that is what that means. That's the real life meaning of that. So the next one says t of what equals 20. So what are we looking for? We're looking for something missing in parentheses, so that's our input, which we said was m, our minutes. So this is saying how many minutes do I have to use to get a total charge of $20. Well, we look at the total charge of $20, which is this guy right here, and we look at the corresponding minutes, and that's going to be 30. So t of 30 equals 20. When I talk on the phone for 30 minutes, I have to pay $20. All right, let's do some more examples with tables. So the first part is f of what equals -2. So we're looking for an input that has an output of -2 in the f row. Well, -2 has an output right here. And we look at its corresponding input above, which is the x row, and that's -3. Oh wait, I'm sorry you guys, I was looking at +2 and not -2. We need to look at -2 as an output. And so the corresponding input is right above it, which is -1. So when I have an x value of -1, f of x equals -2. All right. The next one says g of -3 equals what? So this time I'm given my input x, and I want to know what is my output. So here's my input row, so I circled -3, and then I go down to g, and it says that my output is also going to be -3. So that goes here. Okay. G of what equals 0? So I'm looking for the x value that has an output of 0 in the g row. Well, the g row has 0 right here. And what x value corresponds to it? I just need to look up at the very top to see what x value corresponds to it. And that's -2. So this guy is going to be x equals -2. All right, next one. When x is equal to 0, what is f of x? Well, again, I look at my input of 0, I know that, and then I go to the f row, which is right below it, and I see that the output corresponding to an input of 0 is -4. So that goes right there. Okay, the next one is f of what equals -3. So I'm looking for an input that has an output of -3 in the f column. And that is right here. That's the output of -3. So I look above it, and I see that's the input of 1. So this is going to be 1. Okay, part D. I don't know why this says part D, but I guess part D, part 2, is for which x value is f of x equal to g of x. So we want to look at the f of x and g of x rows as a whole, and we want to see what column they equal each other in. And there's only one column where they're equal, and that is right here. Okay, they're equal right here, and we look at the corresponding x value above it, and it's -1. So x equals -1 is our answer for this. Okay, for which x is f of x bigger than g of x? Bigger than g of x. So where is f of x bigger than g of x? So we just go column by column. So let's start with this column. Is it true that f of x is bigger than g of x? No. So we move on. Okay, let's go to the next column. Is it true that f of x is bigger than g of x? Yes. 2 is bigger than -3, and so our corresponding x value above is x equals -3. All right, we're done with that one. What about the next column? Is -1 bigger than 0? No. We move on. Is -2 bigger than -2? No. It's not bigger. Is -4 bigger than 2? No. Is -3 bigger than -1? No. Is 1 bigger than -4? Yes. Okay, so that's also going to happen. That's going to happen at x equals 2 if you look at that corresponding input above it. Okay, so these are our two answers for this last part of the question.